we have designed a control system for a Kmrr research reactor for Korea, in which we use the programming controllers instead of the conventional control system we used to have so far. And we believe that the programming controller is going to have certain good accuracy, safety, and flexibility. We took into consideration the design requirements from AECL reactor, and we built these design requirements into the hardware of the programming controllers, and we made an algorithm. This algorithm is a program which runs every 200 milliseconds. That program reads the field inputs for the different thermal and neutronic variables, reads the operator input for the set point he wants to put into the reactor, then processes the inputs, taking into consideration the different safety and accuracy criteria, and finally outputs to the control rod mechanism the number of steps needed in order to maintain the set point entered by the operator. Before I embark on the control system, I'm going to go briefly on the reactor architecture. Then I'm going to go through the control block diagram, which means the relation of the programming controller towards the environment. Environment means the reactor controller, the different input instruments. I'm going to talk about the safety considerations we took into consideration, and finally I'm going to conclude. The reactor is an open pool structure which has a plenum with a coolant, which is light water going through chimney, through the pump, through the heat exchanger. There is a control mechanism which is magnetically coupled, and in case of shutdown, we just cut the power to the coil here, and because of the force of gravity, the core falls freely into the rod falls freely into the core. Here we have the different input variables, thermal variables, which means temperatures and flows, and we have also neutronics variables, which mean neutral fluxes from the fission chambers. This block diagram. Here is the block diagram of the programming controller. The environment, the reactor, the fission chambers, which measure. We have to release, and because of gravity, the rod is going to fall into the core. So we magnetize the coil, and then due to gravity, the rod falls into the reactor, and this is a safe way of shutting down the reactor, because if we had some other way driving with the motor, maybe we had some problem. But gravity never fails. So far, this is what has been proven. Okay, here there is another little trick. When the water goes into the coolant, into the plenum, 90% of the coolant goes from here, and 10% goes from a small bypass line. Now the question is, why just 10% we have it through there? The reason is simple. We know very well that there are particulates which, radioactive particulates are created, and because they are very light, they go towards the surface of the pool, and they are going to emerge into the surface and are going to have a lot of radiation. In order to avoid such a thing, we have a small quantity of water here. So, but this water, because it's outside the plenum, what does creates a flow going that way. But because of the system is closed, the water doesn't go to the surface, it has to go back and go back again from where it came from. So by going back, takes all the particulate back again and put them through the system. So we have the radiation at the level at the surface of the pool is not very big. Okay, now in order to there is any problem, sir?
No.
You can ask me at the end if you don't like that. I will try. Now, of course, we have various thermal variables. The thermal variable is the temperature at the chimney, and the temperature at the bypass line, and the temperature at the secondary of the heat exchanger. And another thermal variable is the flow. And then we have also some neutron variables. Well, one, the neutron flux, which is measured by the fission chambers. Okay, I take out that thing now and go to the main topic here, which is the controller. Okay, now what we have here. Here is the reactor core, the one I showed you a little while ago. What happened? Here is the controller, the programming controller, where the algorithm is burned into there. Now what happens is the following. The operator here has a communication with the programming controller and just input a certain demand power that he wants to set the demand power of the reactor so many megawatts. This is an input to the controller, of course. But at the same time, there is input to the controller, the different variables, process variables from the field, which is the fission chambers, which measure the neutron flux. The electronic system of the neutron chamber extracts three variables concerning with the same entity, with the flux. The linear flux, the logarithm of the flux, and the log rate, which is how the rate of change of the flux in unit time. Those are inputted also to the programming controller. Besides the neutronic variables, there is the thermal variables, as I told you a little while ago, which is the secondary control, the secondary control system temperature, we mean the heat exchanger temperature, and the bypass, the flow. All these are also inputted into the programming controller. Those are the inputs so far. And now the algorithm, which I'm going to explain a little while ago, marries these different inputs with some other conditions, and what gets out is now the number of steps to the control mechanism depending on the input variables. If we have, in order to maintain the reactor power at a certain level, we have to pull out the rods or push in the rod or leave the rod at the position they are. So what is going to come out from there is number of steps and positive, negative, which means up or down, increase or decrease in the power. Okay, I caught myself again going very fast. No commas. Okay, but what happens? We want the feedback from the control rods, which means we send something to the control rods, but the feedback is, what is the status of the control rods? They are available, they are unavailable, there is a problem. They move the number of steps we told them, yes or no. All this is come back again to the programming controller as an input for our algorithm. So, now I'm gonna go, if you have not keep in your mind this figure, and we're gonna go and explain now what really the algorithm does.